Welcome to the deep dive. We are jumping straight into what might actually be the most massive paradox in the current enterprise tech landscape.
Yeah, it really is a massive gap.
You have probably seen the headlines lately, or, if we're being totally honest, maybe you are living this reality right now at your own company.
Right.
Everybody is pouring millions of dollars into AI.
Yeah.
Massive, unprecedented investments. And yet over 95% of enterprises are reporting near zero measurable returns on that AI investment. 95%.
Staggering disconnect.
It really is. It's a huge disconnect between the promise of the tech and the reality on the ground.
And what's fascinating here is that the problem isn't the AI itself. The underlying models are incredibly powerful.
Right. The brains are there.
Exactly. The bottleneck is the infrastructure. We see AI performance drop incredibly sharply the moment you ask it to move from an isolated single task prompt, like asking it to write an email, to an actual cross-system workflow. The intelligence is absolutely there, but the data it needs to actually do its job is locked away in completely fragmented silos. We're talking about CRMs, ERPs, and, scattered knowledge bases that simply do not talk to each other.
So the AI is essentially stranded on an island. It has a supercomputer brain, but no hands to actually reach out and grab the files it needs.
That's a great way to put it.
So our mission for this deep dive is all about solving those AI silos. We have a fascinating piece of source material today called Bridging the Gap, introducing the SupportLogic MCP Server.
It's a really critical piece of architecture.
We are going to break down exactly how this technology bridges that gap. For you listening, we'll unpack what the Model Context Protocol, or MCP, actually is. Think of it as the USB-C for AI.
Yep.
We'll explore the underlying architecture, look at how the Zero Trust Security Gateway keeps your data safe, and then we're going to dive deep into 5 highly technical, real-world autonomous workflows.
Yeah.
Because we want to show you why this isn't just theory anymore.
To really appreciate the leap forward that this SupportLogic MCP server represents, we kind of have to look at how we've been forcing integrations until now.
The old way of doing things.
Right. Historically, if you wanted two systems to talk, developers had to write what we call glue code.
Ooh, glue code.
Yeah. These are bespoke, hard-coded, highly brittle API connections. You're writing hundreds of lines of code just to get a large language model to query a specific database.
And it breaks constantly.
Exactly. If an API endpoint changes or if the data structure updates, that entire workflow shatters. That traditional glue code is fundamentally failing modern AI agents.
Because agents are supposed to be dynamic, right? I mean,
Yeah.
They need to reason and adapt, not just follow a rigid, pre-programmed set of instructions like a traditional software script.
Spot on. If we connect this to the bigger picture, an agent needs context to reason. So what does implementing this SupportLogic MCP server actually mean for a developer?
Yeah, let's get into the weeds.
It solves 3 core enterprise hurdles at the root level. First, it eliminates fragmented context. You are finally providing enterprise-grade context so the AI actually knows the current state of your business. It's not operating in a vacuum anymore.
Right.
Second, and this is the massive technical leap, it enables dynamic tool discovery.
Okay, let's stop and unpack this dynamic tool discovery because this feels like a major shift. How does an AI discover its own tools?
Well, instead of a developer hard-coding a specific API call for a specific task, like writing a script that explicitly says, if X happens, call API YI, the MCP server allows the AI agent to just ask the server at runtime.
Ask it what?
It asks, what tools do I have available right now? The AI essentially queries its environment and discovers it can use things like sentiment analysis or escalation prediction on the fly, entirely based on the problem it's trying to solve in that exact moment.
Wow. Here's where it gets really interesting for you listening. Think about your own experience trying to force different software platforms to communicate. It is always a headache.
Oh, absolutely.
You are dealing with authentication, parsing different data formats, managing rate limits. It takes weeks of engineering time. Standardizing this integration layer with MCP fundamentally changes the game. You aren't building a custom bridge from scratch every single time.
You are just plugging the AI into the universal port.
The USB-C for AI.
That analogy holds up perfectly. And then the third hurdle it solves is operational grounding. It ensures that the LLM's outputs are anchored in real-time operational signals.
So no more hallucinating based on old data.
Exactly. We're talking about grounding the AI in live escalation risk or current account health instead of some static CSV file that was exported 3 days ago.
So if we look under the hood here, The source material emphasizes that this MCP server is fundamentally different from a traditional REST API.
Yes, very different.
Because when I hear REST API, I think of a very literal point-to-point data fetch. Give me this user profile, update this record. It doesn't really leave room for reasoning.
Right. REST APIs were built for deterministic software. You tell it exactly what to do, it does it. The SupportLogic MCP server, however, is built around what we call AI native primitives.
The primitives. The source outlines 3 core building blocks here: tools, resources, and prompts. If you are listening and wondering what a primitive actually looks like for an AI agent, let's break that down.
Let's start with tools. In this ecosystem, tools are executable functions that allow the AI to perform actions with side effects.
Meaning it actually changes something.
Exactly. This isn't just reading data. This is the AI actually executing a command in the real world, like reassigning a case owner in Salesforce or triggering a downstream Slack workflow.
Okay, got it.
Next, we have resources. These are your read-only data objects. Think of them as the background knowledge. The AI references specific ticket details, knowledge-based articles, historical customer context.
So if we use an analogy to make this concrete, tools are the hands. They actually do the work and change the environment. Resources are the memory, the files the AI reads to understand the situation.
That's a really good way to visualize it.
And then the third primitive is prompts. Where do they fit into the hands and memory analogy?
Prompts are your guardrails. They are predefined templates that guide the AI through complex, multi-step workflows to ensure consistent outcomes.
Like formatting a specific response.
Yes. If you want the AI to draft a professional response to an angry enterprise customer, the prompt primitive provides the structural guardrails. It ensures that the draft meets your corporate tone and enterprise standards every single time, rather than letting the LLM just freestyle the response and risk saying something inappropriate.
Now, you can have the best hands, memory, and guardrails in the world, but if the underlying connection is dropping, your AI agent is completely useless. Let's talk about the transport layers.
Good pivot.
The source mentions STDIO and SSE. If you are listening and those acronyms sound like a bowl of alphabet soup, let's clarify. Why are these specific transport mechanisms so important?
It comes down to reliability and the specific environment where the AI is operating. For local development or highly secure on-device assistance, like if you're running Claude Desktop natively on your machine, they use STDIO.
Which stands for Standard Input Output.
Right. You can think of STDIO almost like a direct, secure physical wire inside your computer. It is incredibly fast and secure because the data never leaves the local environment. But for remote connections, they use HTTP coupled with SSE,
which is server-sent events. For the listener who might just be used to standard HTTP requests, why is SSE the chosen method here instead of just regular web traffic?
Because normally your browser or client has to keep asking a server, do you have any updates? How about now? How about now?
Polling.
Yes, polling. It's wildly inefficient. But with SSE, it's like leaving a radio on in the background. The server just constantly broadcasts the live analysis and streaming updates back to the AI client without being constantly polled.
So the AI can just listen and react.
Exactly. It allows the AI to react in real time.
That makes total sense. And then there's the wrapper for all of this communication. I saw JSON RPC 2.0 mentioned in the source material. Honestly, reading about structured error handling usually puts me straight to sleep.
Yeah, it's pretty dry.
But the notes highlight this as an absolute game changer. Why is it so crucial in this context?
Because this raises an important question about how AI actually learns from failure. If an agent tries to execute a tool and misses a required parameter, say it tries to reassign a ticket but forgets to include the user ID, a standard error might just crash the script.
Or pop up a generic error code.
Exactly. But the JSON RPC 2.0 error response tells the AI exactly what went wrong in a highly structured, predictable format.
Wait, let me stop you there. So if an agent misses a parameter, it doesn't just fail and send an error alert to a human developer to fix it. It actually reads the error log itself.
Yes. The AI reads that structured error, understands its own mistake, adjusts its request to include the missing user ID, and tries again autonomously.
That is wild.
It self-corrects mid-task. No human intervention required.
The machine debugging itself. But if you were sitting there listening to this, I know exactly what you're thinking. Wait a minute. We are giving autonomous AI agents the power to dynamically discover executable tools, read my secure enterprise data, and just self-correct their own actions in the background.
It sounds scary.
It sounds like a massive security nightmare waiting to happen.
It is a totally valid concern, and it's exactly why the architecture isn't just a free-for-all. It includes a zero-trust MCP gateway.
Okay, let's break that down.
If you picture the architectural model, you have your MCP clients on one side, that's ChatGPT, Claude, your custom LangChain agents. On the other side, you have your underlying business tools, your CRM, your data lake.
And the gateway.
Sitting right between them, acting as the absolute authority, is the MCP gateway.
So the gateway is the bouncer at the club. Nothing gets past it.
Exactly. It enforces a strict zero-trust model. Let's look at how these security layers work in practice. First up is authentication and authorization.
The ID check?
Right. Before a single tool even loads, let alone executes, the gateway checks the request. It supports unique per-user API keys for developers and enterprise SSO via OAuth. So it ties directly into your company's existing identity provider.
So if an employee leaves the company,
their AI agent loses access the very second their SSO is revoked.
And then there is granular scoping, which prevents what the source material calls privilege creep. I love this concept. Let's expand on our bouncer analogy. Granular scoping is like giving the AI a key that only unlocks the front door, but absolutely will not open the safe in the back room.
That is a perfect way to look at it. The permissions are bound strictly to intent. If you authorize an AI agent to read sentiment signals from a support ticket, it absolutely cannot trigger a case reassignment unless you explicitly granted it that specific separate permission.
It fences the AI in.
It severely limits the blast radius if an agent gets confused or if a prompt injection attack occurs.
But if we are locking down permissions that tightly, how do we actually keep an eye on what the AI is attempting to do in the background?
That brings us to governance and audit trails. If you've ever tried hunting through fragmented client-side logs to figure out why a piece of software did something weird, you know the pain.
It's the worst.
Here, every single tool invocation is logged with full context at the gateway level. You see exactly who made the request, what tool was called, what data was accessed, and what exactly was returned.
So the audit trails is totally centralized. No more hunting.
Right. And building on that, there's real-time monitoring. The gateway continuously tracks the frequency of tool calls.
Why frequency?
To establish a baseline. If an agent suddenly deviates from its baseline, say, it normally checks 5 tickets an hour, but suddenly it starts firing off hundreds of escalation, triggers the system, detects that anomalous pattern, and alerts your engineering team in real time before it spirals into a massive problem.
That's smart. With that secure foundation firmly in place, we can actually look at the intelligence toolbox itself. The real magic of this architecture is how it transforms your historical, unstructured support data into ready-to-use tools.
Let's look at what's in the box.
All right, speaking directly to your inner developer listening right now, you are probably wondering what this actually looks like in practice. What specific intelligence tools is SupportLogic injecting into these AI agents?
There are a few standout tools they provide right out of the box. For signals and insights, you have extract signals.
What does that one do?
This analyzes text or structured case data in real time to detect customer sentiment, urgency, and even emotional tone. Then there is list of escalations, which identifies cases that are already escalated or, more importantly, likely to escalate based on early warning patterns.
Nice. And for quality control?
They mention the Autoka tool, which automatically evaluates case quality, customer effort scores, and agent performance.
Plus, for knowledge search, they have this fascinating tool called corpus clarification.
That one is really unique.
It actually forces the AI to resolve ambiguous questions with the user before it executes a search, which massively improves the accuracy of the answers it retrieves. So how do we get these tools into our environment? How do you actually wire this up today?
It's surprisingly straightforward. First, you need your universal setup requirements from the SupportLogic platform. That's your remote MCP server URL and your personal client ID.
Okay, got those.
From there, the integration depends on your client. If you're using Claude Desktop, and note you do need the Pro plan for this, you can use the built-in UI to add a custom connector, or just drop the URL into your Claude Desktop config.json file.
Super easy. For the ChatGPT Plus or enterprise users listening, you just toggle on developer mode in your advanced settings, create a new connector, and drop in that same SupportLogic URL and client ID.
And for the engineers practically living in AI-powered editors right now, if you're in VS Code with GitHub Copilot, you just pop open the command palette, search for MCP ad server, select HTTP streaming, and paste the URL.
Same process for cursor, right?
Exactly. Just go to Settings, select MCP, and add a new global server using the streamable HTTP type.
But the real developer shortcut here, the magic bullet, is the CLI installation. It's a one-command installation. You just open your terminal and run npx add mcp php https.mcp.supportlogic.iomcp.
That's all it takes.
That single command automatically configures the server across Claude, Cursor, and VS Code simultaneously. Just brilliant execution to make adoption that frictionless.
So we have the tools, the security gateway, and the dynamic discovery. Let's look at what happens when we put it all together into real-world agentic orchestration, running autonomously without human intervention.
This is the so what of the whole deep dive. The source material outlines 5 highly technical use cases that prove how powerful chaining these tools together really is. Let's spend some time on these because the contrast between how humans handle these problems and how the AI handles them is incredible.
Where should we start?
Start with scenario 1, the executive briefing. Imagine a VP gets pulled into a critical enterprise customer call with exactly 30 minutes notice. Usually this is absolute chaos. You have support staff frantically scrambling through Jira and Salesforce trying to stitch together a history.
But with the MCP server connected to an agentic framework running in Slack, that scramble disappears entirely. It's fully autonomous.
Walk us through it.
The calendar event flags the escalation. The AI agent immediately calls the case details tool to get the ticket timeline. In parallel, it calls the account details tool to pull the customer's historical sentiment and health score.
It's pulling all this at once.
Yes. Then it uses the prompts primitive to chain all that raw data into a crisp, readable executive summary outlining the root cause of the issue and the customer's emotional arc. That brief is waiting in the VP's Slack thread before they even open their laptop.
No scrambling. No walking into a multi-million-dollar account meeting completely blind. Okay, scenario 2. Backlog triage after a 2 a.m. platform outage.
Oh, this is a painful one.
If you've ever been on call, you know this pain. By morning, you have 600 tickets sitting in the queue. You have basic informational questions mixed in with Fortune 500 customers whose entire production environments are totally blocked. Usually, queues are first in, first out.
Meaning your biggest client is stuck waiting behind a password reset just because they emailed 5 minutes later.
Exactly. So how does the MCP handle it?
To solve this routing nightmare, an agent uses the extract signals tool across all 600 tickets in parallel. It analyzes the sentiment, urgency, and customer tier of every ticket simultaneously.
And then it sorts them.
Better than sorts. The agent clusters the tickets, entirely bypasses that standard FIFO queue, and routes those production-blocked enterprise accounts directly to senior available agents.
Wow.
Finally, it automatically generates a signal report for the incident retrospective, all done in seconds with 0 manual sorting.
Scenario 3 is about 100% QA coverage. We all know that manual quality assurance usually only samples maybe 5 to 10% of resolved tickets. There are simply too many tickets and too few managers. Most coaching opportunities are completely missed.
Right. Here, a scheduled nightly agent runs the AutoCode tool across every single ticket resolved that day.
Every single one.
It provides true 100% coverage. It evaluates adherence to company guidelines and measures customer effort scores. The agent aggregates the data, surfaces the statistical outliers, and uses prompts to deliver same-day coaching notes directly to the support agents.
So the managers just read the summaries.
Exactly. Supervisors then only need to review the flagged outliers, effectively giving you total QA coverage without adding a single QA headcount.
That is incredible leverage. Scenario 4 focuses on SLA breach prevention. Usually, teams are putting out fires after an enterprise service level agreement is already breached, which means you are already issuing refunds or apologies.
But here, a persistent monitoring agent pulls all open, high-priority cases every 15 minutes.
Proactive instead of reactive.
It changes the whole dynamic. If a case hits a configurable threshold, say, it detects 2 hours of inactivity, and the breach is approaching, the agent autonomously fires a tool chain.
What tools does it chain?
It calls case details for context, reassigns the ticket to an available senior agent to get eyes on it, and pushes a Slack alert to the on-call lead with a live countdown timer.
Fixing the issue before it's even officially a breach. And finally, scenario 5. Cross-account trend detection. A new firmware bug pops up. In a standard setup, you see isolated complaints in individual agent queues. And by the time engineering actually notices a pattern, dozens of customers are furious.
But with a nightly agentic workflow, the extract signals tool processes all cases updated across all accounts in the last 24 hours.
Untick your patterns.
The AI is specifically looking to cluster emerging themes. If an isolated firmware complaint suddenly spikes across multiple, totally unrelated accounts, the agent catches the pattern before it becomes a massive escalation wave.
And because of that dynamic tool discovery we talked about earlier, the agent can simultaneously push a structured alert directly into Jira for the product team, Slack for the engineering channel, and Salesforce for the account managers.
It does all of that at the exact same time without a human developer ever having to hard code those 3 separate integrations.
It transforms your basic support data into a real-time product intelligence feed.
It's a totally new way to operate.
So to summarize what we've unpacked today for you listening, the SupportLogic MCP Server represents a fundamental shift in the enterprise tech landscape. We are finally moving away from those brittle, static, human-written glue code integrations. We're moving toward a context-rich, standardized protocol that actually lets AI reason about its environment, dynamically discover the tools it needs, act autonomously with strict zero-trust guardrails, and provide unprecedented precision.
The pieces are finally connecting.
The gap between your siloed enterprise data and actionable AI has officially been bridged. It is time to start building. If you want to get your hands on this and see it in your own environment, you can reach out directly to them for access by emailing mcp@supportlogic.io.
I want to leave you with one final thought to mull over today. If AI agents can now dynamically discover their own tools at runtime, and if they can read structured JSON RPC error logs and self-correct their own mistakes.
Which is still blowing my mind.
Right. And if they can autonomously chain complex workflows across enterprise data silos without any human-written glue code, what happens to the traditional role of software integration?
That's a big question.
Will the next generation engineers stop writing APIs entirely and instead just write intent scopes and security guardrails for autonomous machines?
That is a wild thought to leave off on. The future of software might just be managing the boundaries, not writing the bridges. Thank you for joining us on this deep dive, and we'll catch you on the next one.